Let's move on. Generics 1. Vec T is generic over the type T. In most cases, the compiler is able to infer T. For example, after pushing a value with a concrete type to a vector. But in this exercise, the compiler needs some help through type annotation. So we need to tell it, don't change the lines below. Fix the compiler error by annotating the type of the vector T. Choose a T as some integer types that can be created from U8 and I8. Okay. We can make it a vec of I16s. That should work. Yeah. All right, so that was type annotations. I'm not sure how that helps with generics, but let's keep going. Generics 2. This powerful wrapper provides the ability to store positive integer value. Rewrite it using a generic so it can support any wrapping any type. Okay, so here's what we're actually doing. We're being able S to be specifying a T there, and we can put a T there. Then we have to say impl T wrapper T for blah, and then this becomes T. Is that all they're asking us to do? Yeah. So this just changes to use any type. Okay, so that was generics 2. What's next? Generics 3? No, traits 1. Okay, so we're going to traits. The trait append bar has only one function, which appends a bar to any object implementing this trait. Implement append bar for type string. Okay. So what we can do is we can start by using the editor to add that. Put that on top. And we have a string and it's owned. And we'll return a string. Oops, I didn't expect that. But okay. So I think all we have to say is format bang self bar. Right. Oh, and looking at the test, it looks like it needs to be uppercase or capitalized. Okay. Yep. That was traits. We seem to be ripping through these guys here. Let's go to traits 2. Scoops has an alternate solution: self push stir bar self. We can do that. It's a little, ooh, you have to say mute here in order to do that. Right? But that's a little more work. All right, so this says implement the trait append bar for vector of strings. Append bar should push the string bar into the vector. Okay, so we can say impl append bar for vec string. Fn append bar self, and this would be self dot push bar self. Okay, this just needs to be let's see if we can do into here. And this needs to be mutable. There we go. Yeah, I'm just looking at the test, and that's all doing. It's starting with a single vector string of foo, append bar. Let's see if we can push to empty vec. I think you can. It should be able to. Let mot vec vec new. And then I should be able to say vec append bar. Let's see if we can infer the type from that. And then assert EQ one veclen. Oh, because the way this does, append bar actually transfers ownership. So we actually have to say vec equals. There we go. Interesting. All right, so it works for that too. I mean, I knew it would. It's just that, you know, it seems like it would be, that would be another test to do if you were writing this kind of thing for real. What's next? Traits 3. Trait licensed. To do, add a default implementation for licensing info so that implementers like the two structs below can share that default behavior without repeating the function. Okay. And saying don't edit this line. So what we need to do is implement something where we can call licensing info. Okay, so we have licensing info equals default license, some software version number 1, other software version number 2 string. So we should be able to call licensing info and have it equal to this. Should just say default license. I think that's what they're looking for. It's a little confusing because it seems like you would want to return these guys, but then it'd be coming in another rustling. But here we're definitely just looking for the string default license. Right, that's all we're looking for. We're ignoring the version numbers in both of these guys. Okay, very good. So they're just trying to teach us about the fact that you can create a default implementation for a trait, as long as it's generic enough, right? Traits 4. Come on. Oh, because I'm in this thing here. All right. Yeah, so this is all we did. This line here. Okay. Fix the compiler error only by changing the signature of this function. Compare license type, software 1, software 2. Okay. So are we just looking for something that implements licensed? No, we can't do that. Oh, I typed it. I typoed it. That's why. Yeah, so that's all they're looking for. We should be able to do this, right? Oh, right, because they have different license types. So let's say Elm. Yeah, we'd have to do it that way. Yeah, Scoop says only if there's the same type. Yeah. All right, so this is using the I don't know what you call this here. Trait bounds for the thing, but I think they were just looking for impl license here. Okay, so that was traits 4. Traits 5 is next. 5. Expected identifier found. Oh yeah, because the question marks. Okay. Fix the compiler error by only changing the signature of this function. All right, so what do we have? We're comparing some function to other function and other function. Both of them return Boolean. And we have some struct and an other struct. And we're implementing both some trait and other trait for each of them. So item needs to be able to implement both. Can you put pluses on the line here? No, it's not liking that at all. expected 3 arguments, found 1. So you can't add them like, oh, you don't put the impl. Interesting. Ah. And again, I think you can use it using that same trick. Feature, some trait, other trait. Let's see if this works as well. Yep, it works. So both of those work. Very good. Next. Quiz 3. Oh, we're up to quiz 3. Very good. This quiz tests generics and traits. An imaginary magical school has a new report card generation system written in Rust. Currently, the system only supports creating report cards where the student's grade is represented numerically. However, the school also issues alphabetical grades and needs to be able to print both types of report card. Make the necessary code changes in the struct report card and the impl block to support alphabetic report cards in addition to numerical ones. Okay, so I think what they're saying, so it's saying adjust the struct as described above. So right now we have only numerical ones. So, but if we make it generic on type T, we can do that and then make this impl this. We are going to have to make it, because it's being printed out, we're going to have to add the display trait. Right? Otherwise it won't be able to be printed. Is that all we need to do? We have Tom Riggle with a floating point grade. You've got Gary Plotter with a string grade. And then we need to be able to print out, yeah. Is that all? That's the whole quiz, is to make that generic. I guess the tricky thing is if you didn't know, if you leave this out, it's going to complain saying it can't be formatted with the default formatter. And it'd actually tell you to insert the display format. And obviously the way the cool kids do it is by putting a use up there and then putting the colon display here. But you can only do that if you're cool.